Hello, in this lesson we will be learning about molarity mostly for a unit of concentration in solutions. So here we have some concentration units that we learned in the past. We have molarity, which is moles over liters, molality, which is moles over kilograms of solvent. We won't be using that at this time. And there's also mole fraction. All that is, if you're interested in the moles of A, you put the moles of A on the top over the total moles, which is 10. 8 plus 2 is 10 moles total. And mole total, this is A. 2 over 10 is 0.2. And it stays as a fraction, and this is the mole fraction of A. A symbol for mole fraction is an idolized X, A. Okay? So let's now focus on molarity. So first, in order to make a solution, we could use a volumetric flask. What we do is we take the solid sample using the formula molarity is equal to moles per liter. If the sample is a solid, you take the moles that you need by knowing the molarity and knowing the amount that you want. You multiply, you'll get the moles, convert that to grams, and you'll know how much to weigh. You then add it to a volumetric flask. And for example, this volumetric flask will have a little line that corresponds to the volume. So let's say this is 50 milliliter volumetric flask. It'll give you that much solution total. So whenever I say volumetric, the glassware is very accurate. This 50 milliliters has a lot of significant figures, and this glassware is very expensive. So we use volumetric if we want to be very accurate in making solutions. You can also do some dilutions. When you're doing a dilution, you have to use the formula N1V1 is equal to M2V2. As opposed to making a solution using a solid, for example here, this one's a little bit different. Here, your substance is in water already, so it's already an aqueous solution. So let's say that this is your original solution. You're going to take a part of it using a pipette, transferring it to another volumetric, and then you're going to add water to it. This is now the diluted sample. When I say dilution, I mean you are watering it down or just adding water to it. The formula is as follows. This is pretty much M1V1 equals M2V2. This is what you have on this side. This is what you want. Okay, so let me give you an example of how to do that problem. How would you prepare 500 milliliters? So this is what I want, and this is what I want. So these are the final solutions, what I want in the end. From a stock solution of 4 molar, this is what I have in the beginning. So you're going to do M1V1 is equal to M2V2. What I have is the initial. I have a 4.0 molar already in water. Therefore, I'm going to use this formula. I need to find out how much of that original I want. And in the end, I want a 2 molar solution. And I want 500 milliliters of it. You then solve for X. X is equal to, go ahead and pause the video and solve for that, please. Okay, I found 250 milliliters. So to make the solution, you will take 250 milliliters of the original solution, which is the 4.0 molar NaOH, and you will add to it, you want a total of 500 milliliters, right? So you will add 500 minus 250, which is 250 milliliters of water. So in the end, when you add these two numbers, you should have 500 milliliters total, which is what you desire. Okay, and that's how you use that dilution formula. Now, you can also use molarity in a titration reaction. Titration is just a way of adding two liquids together. You use something called a burette, and you're adding something. Let's say this solution right here, you don't know the molarity. You don't know. By using something that you know. And using stoichiometry, you can find out the molarity of the unknown. Here's an example. Oh no, not this one yet. Let me just do this problem. Sample exercise 4.12. What are the molar concentrations of each ions in 0.025 molar aqueous solution of calcium nitrate? So first, I have to know how to write this substance. Calcium, what charge is it? +2. Nitrate, you memorized it. It's NO3 minus 1. To write calcium nitrate, you will need 2 of these to make it neutral. Therefore, calcium nitrate is CaNO3, 2. So you have 0.025 molar solution of CaNO3. Okay, so they're asking what are the molar concentration of each of the ions. The two ions are Ca plus 2 and, oops, that's an A, and the other one is NO3 minus 1. So it's asking what's the molar concentration of Ca plus 2. Let's do that one first. Well, for every 1 molar of CaNO3, 2, how many molar of calcium? It's also 1. Calcium plus 2 ions. Okay, because in this substance, there's only 1 calcium ion for every 1 calcium nitrate. So the answer is the same, 0.025 molar calcium plus 2 ions. Okay, pause the video and do the next one. Do nitrate now. Okay, good. So if you have 0.025 molar CaNO3, 2, for every 1 molar CaNO3, you will have how many nitrates? You're right. Because of that, there are 2 NO3 minus 1. Nitrate is a negative 1 charge. Therefore, you will double the amount. 0.025 times 2 is 0.050 molar nitrate ions. So that's how many nitrates ions you will see in this solution of aqueous calcium nitrate. Okay, again, when looking for when using the molarity formula, okay, I'm going to use this as a conversion factor. This is the same as 0.500 moles of Na2SO4 for every 1 liter of the solution. Therefore, I'm going to start with a singleton right here, 0.35 liters times for every 1 liter, there is 0.500 moles. You're going to use this as a conversion right there. Okay, that's the same as molarity. Na2SO4. Then you're looking for grams. You should just change it to grams. 1 mole of Na2SO4. You're going to get the molar mass, 142.0 grams Na2SO4. You multiply that and you will find 24.9 grams Na2SO4. Okay, easy. That's how you use the molarity. This one is another dilution. I think you can, let's see, how many milliliters of 3 molar H2SO4 are needed to make 450 mils of H2SO4. Okay, so you're just diluting it. You're already in an aqueous solution. Which formula should I use? Should I use molarity is equal to moles over liters? Or should I use M1V1 is equal to M2V2? You're right. You should use M1V1 equals M2V2. The reason you do that is because the original solution is already in water. Okay, pause the video and try this yourself. Okay, so M1V1 is equal to M2V2. How many milliliters of 3 molar? So that's the original, 3.0 molar. And that's X equals 0.10 molar. You're diluting it from 3 molar to 0.1 molar, and you want 450 milliliters. Solving for X, you're going to find 0.015 liters of the original, which is the 3 molar H2SO4. Okay, pretty easy. Now you're going to be using molarity in a stoichiometry. So neutralization just means you're taking an acid, which has H plus, and a base, which has OH minus. Okay, it's just another way of saying you're mixing them together so then they react. So here are the two reactants: calcium hydroxide And the reason there are two OH minuses is because this is a -1 and that's a +2. So you will need two OH minuses. And nitric acid. So this has nitrate is -1, H is +1, so you just need one of each. When you're reacting them together, the H and the OH, so you have H plus and OH minus. Okay, because the charge is +1, -1, you just need one of each. You're going to make water. The 2 right here, down here, you're going to use that later when you're balancing the equation, okay? So just ignore that. Just focus on the charge. Here you have calcium and the nitrate. You will make calcium, which is +2, and nitrate is -1. So how many nitrates do you need? You're correct. You need 2. After you do that, you may erase all the charges because you just needed them so you can form the products. Then I'm going to balance the equation. Let's use this one. Say 1 calcium, 1 calcium. I'll do the nitrates next. 1 nitrate, and there are 2, so I'm going to put a 2 right here. You have 2 H's. 2 H's makes 4 H's. I'm going to double here. 2 O's and 2 O's, and then balance. It says, how many grams of calcium hydroxide, so you're going to put a question mark here, are needed to neutralize. Neutralize means these two neutralize each other or they just react. 25 milliliters, you have 25 milliliters of this, of 0.1 molar, okay? Instead of writing the molar, I'm going to write moles per liter. So what I will do here is I will use the molarity, this is the molarity, as a conversion. There's the one there. I'm going to use these together to go to moles here, and then go to grams. Okay, this is my singleton. That means a single unit, and I'm going to start my problem there. Okay, so pause the video and try it yourself. All right, so I'm going to take 25.0 milliliters of HNO3, changing that to liters, and then I'm going to use this here. For every 1 liter, there's 0.100 moles of HNO3. Okay, then I'm going to drop the moles HNO3. This is now the mole ratio to the moles of CaOH2. Okay, there's a 1 here, so there I'm going to put a 1 right here. And there's a 2 there and a 2 in front of that. That's the mole ratio for every 1 calcium hydroxide. I will need 2 moles of HNO3. Okay, so now I'm canceling this unit, and this. Now I'm going to go to grams because it's asking for grams. 1 mole of CaOH2 is 74.1 grams. So you just add 1 calcium and 2 O's and 2 H's, and you get the molar mass. The answer is 0.0926 grams of calcium hydroxide. Okay, let's try this problem. The quantity of Cl- in a municipal water supply is determined by titrating. Titrating means mixing together or adding. You have Ag+, which is right here. The reaction taking place is this right here. So you take the Ag+, Cl-, and you will get a precipitate. It's the white solid called AgCl. The end point of this type of titration is marked by a change in color of a special type. So you know it's done because the color changes. How many grams of chloride ion, so you're going to go question mark, grams, are in the sample of water if 20.2 milliliters of the Ag+, so this goes here, you write that down, 20.2 milliliters of 0.1 molar Ag+, so I'm going to write 0.100 moles for every 1 liter. Again, you're going to write this as a moles per liter is needed. Okay, so again, you're just going to do stoichiometry. You're going to go grams, you're going to go to moles, you're going to go to moles. No, I'm sorry, you're going to go here first, moles, and then you're going to go to the right and then up. Okay, because you don't know what the grams is. So let me start that problem. Go ahead and pause the video and see if you can do it yourself. Okay, here we go. So you start with 20.2 milliliters of Ag plus. 1,000 milliliters is 1 liter. I'm going to use this ratio now. 1 liter is 0.100 moles of Ag plus. Okay, times, drop the moles Ag plus. For every 1 mole of He plus is 1 mole of Cl minus, and then go to grams because that's what they want. For every 1 mole of Cl minus is 35.4 grams Cl minus, equals 7.17 E negative 2 grams Cl minus. Okay, easy. And then letter B. Let's see, if the sample has a mass of 10 grams, so that's the total in the bottom, total sample, just like your lab. In this case, it was the 1.0 grams of the crystal. 1% of Cl minus, so this will go on top. 7.17 E negative 2 grams times 100 is equal to 0.717% Cl minus. Okay, next problem. One method used to peel potatoes is to soak them in sodium hydroxide for a short time, removing the NaOH. The concentration of NaOH is normally in the range of 3 to 6 molar. The NaOH is analyzed periodically. Okay. In one such analysis, 45.7 mils of 0.5 molar H2SO4 is neutralizing NaOH. So the first thing I need to do is write an equation so I can write all these givens. I'm going to go ahead and write the charges so I know what to do when I'm doing the double replacement. H is a +1 each. There are 2 of them. Sulfate's a -2. Na is a +1. OH is -1. So when I'm mixing the H and the OH, I will make H is a +1. OH is a -1. So I'll just make one of them, which is water. So I'm going to erase that and make water. Oops. HOH is just water. Plus, Na is a +1. Sulfate's a -2, so I will need 2 Na pluses, Na2SO4. Okay, because there were 2 H's here, I have to now balance it. Let's see. Na, there's 2 Na, so put a 2 there. 1 sulfate, 1 sulfate. There's 2 H's, 4 H's, so I need to put a 2 right there, and then 1 O right here. Oh wait, 2 O's. Okay, that's the balanced equation. Go ahead and try to do the problem yourself. Pause the video. Okay, so now I'm going to write the givens. So NaOH is 45.7 mil, and that's H2SO4, so I'm going to write it right here. 45.7 milliliters, 0.500 moles over liters. Okay. Neutralize 20 mils, 20.0 milliliters. And what's the concentration of this in molarity? Okay. So what I will do is I'm going to take this, go to moles, and then go to molarity, which is equal to moles over liters. So I'm going to, once I get to moles, I'm going to plug it in on top, and then this will go on the bottom. Okay, just watch. So I'm going to start with 45.7. (1,000 milliliters is 1 liter. I'm going to use the molarity now. 1 liter is 0.500 moles of H2SO4. Okay. Mole ratio for every, there's a 1 there. 1 mole of H2SO4. I have 2 moles of NaOH. Get the answer, which is 2. Let's see. Oh, I don't know what it is. Whatever it is, I'm going to take that number and divide it by the liters, which is, this is 1,000 milliliters is 1 liter, which is 0.0200, put that on the bottom, 0.200 liters. And the final answer is 2.28 molar NaOH. So you just found the molarity of something that you don't know. Okay. Last problem. I think for this one I will make another video because it's going to be kind of long.